Hello fellow Scratchers, I'm Griffpatch and this is part 3 of our classic Scratch platformer tutorial. Today we are going to learn about player animation and hitboxes. Have you heard of the term hitboxes before? Up until now our player has been a square. Today we are switching to using a cat-shaped costume. Sprite collisions suddenly become more problematic. This is where hitboxes come in super useful, solving many of our collision woes. Stay tuned to learn why. This is a fun episode that will transform the look and feel of our game, and the animation will really bring things to life. We'll begin where we left off in episode 2. Make sure to save the project as a copy from the file menu. This is now episode 3. Okay guys, let's get scratching. To teach about player animation and hitboxes, we are going to be switching to using the Scratch Cat costumes. These were included in the original resource project that many of you will have remixed from episode 1. If you want to use your own costumes, that's no problem at all, but you will have to adapt the tutorial a little to make it work. But I hope it'll be clear enough where. So scroll down to costume 28. It's named Stand. Here is Scratch Cat in his idle standing pose. It's worth noting, especially if you want to use your own costumes in the platformer, how a costume is positioned on the editing canvas. This is really important and shouldn't be overlooked. This is the center of the costume canvas, and when you place or draw a player costume, you want this point to be the middle of the player costume too. The reason that this is important is that as a sprite is rotated or flipped left and right in your game, this is the position they are rotated and flipped around. An off-center costume leads to an off-center movement, like this. A correctly centered one looks much more professional, right? Good. Don't forget, Scratch provides a helpful way to make things centered. As you move a shape around, it will snap to the center of the canvas as you draw close enough to it. This allows you to keep things all nicely lined up. Okay, lesson over. With our standing sprite selected, I'm going to run the project. Wowzers! That is one large Scratch Cat! This level was really designed for a much smaller player, but anyway, it's kind of fun since we will be able to check out his animations easier this way. So to compensate for his size, open the Code tab and we'll set the jump force to say 17 or 18. Running that again, right, now I can reach the first platform in a single leap. So things seem to be working okay. What's all the fuss about needing hitboxes then? Ah, look at this. If I edge off this platform, my face catches on the side and I'm able to continue walking even on my whiskers. That's rather unnatural, right? I can even still jump. Yeah, these whiskers can be useful climbing tools apparently. It's surprising that they are so robust. Ha! So why didn't we see this happening with our cute guy character? The answer is quite straightforward. They were a perfect square, with no sticking out features that could get caught on the level. Luckily for us, with a little work, we can have the best of both worlds. We just need to use, you guessed it, hitboxes. To demonstrate this, click back into the costume editor and find costume 28. Here it is. So to create a hitbox costume of my own, start by duplicating costume 28. Then, select the entire costume on the canvas. We can then group the whole costume together using the group button. This will make our lives easier as we draw the hitbox. Next, with the rectangle tool, draw a bounding rectangle around Scratch Cat. It should only just cover them, don't make it too big now. The important thing is that there are no parts of the cat sticking out past the rectangle. Excellent, let's run the project. This is really quite funny to see. It's Scratch Cat like you've never seen him before. The Scratch Cat in a box platformer, yay. But here's the thing. Did you notice that the box around our player is actually stopping us getting trapped on the edge of platforms? This is good news. Okay then, so if you are still following along, then I just need to report that this large sprite will get stuck trying to move onto scene 2. This is because the level wasn't designed for such a big character. We'll not worry about that now, but it does make me realise that it's not so easy for you watching this video to see when my player does get stuck. For all you know, I may just not be pressing any keys, so how about I make the background change to bright red when we get stuck? Oh, before we do any coding, ensure we name this costume Big Hitbox. Okay, sweet. Come into the code and find the when I receive tick player script. We should simply never be touching the ground at the start of a tick player. So if we are touching level, then we are stuck. To switch the backdrop colour, we can simply switch backdrop to, and this is the clever bit, the touching level block. Wow, that's weird, isn't it? This will change the backdrop costume to a costume named true or false. True if we're touching the level, and false if we are not. Okay, we can work with that. Click into the stage backdrop and make sure we have 2 free backdrop costumes. I'm creating a new second one. Name the first one false and the second one true. So remembering that we changed the backdrop to true if we are touching the level, we therefore want this costume to be bright red. Nice. Did you know that red was my favourite colour? We'll leave the false costume blank and give things a test. By staying in the project view, we can just drag Scratchcat and drop them overlapping the level. Boom! Look at all that redness. We must be colliding. Good job. I can also test it by walking off the right. Yeah, now it's clear. We are stuck. I can now use this to better explain why, even when using Hitbox costumes, we can still have issues with sprite collisions. For this, we need to talk about sprite rotation and sprite rotation styles. Our guy sprite was designed for simplicity, and he only ever faced one direction. Scratchcat, on the other hand, wants to face in the direction they are moving in, and herein lies our problem. Let me demonstrate. Click into the player's direction box here. Up pops the direction dialog. Do you see these 3 icons across the bottom? Using these, we can choose between 3 possible rotation styles for each sprite. Click on the first one. This is the all-around rotation style, and is the default for all new sprites. In this style, I can rotate the sprite freely. This is really great for, say, a space shooter or any top-down style game, but not so great for a platformer. It does highlight, though, that rotation must be considered when thinking of collisions. You see how changing the direction is causing the sprite to collide with the level even though its position is not changed. Okay, so next up we have the left-right rotation style, the middle option. This is the style used by the default Scratchcat, where changing the sprite direction no longer causes them to rotate, but instead they turn to face the left or right. Well, that's cool, behaving as you would expect in a platformer game. Also, look, no bright red backdrop as we turn. So this mode seems better suited to hitboxes as the costume is not coming into contact with the level as the costume is flipped left or right. But there is still potential for problems. If I walk flush up against the wall to the left and then change direction, did you see we appeared to move further away from the wall? Okay then, walk up closer and turn around again. Boom! Again, we are stuck in the wall. Yes, even tiny differences caused by flipping the hitbox can cause our sprite to get stuck. This is possibly one of the most common bugs that I've seen in Scratch's platforming games. Luckily, there is a simple solution. The final rotation style is the Do Not Rotate style. As the name suggests, with this enabled, the sprite doesn't follow the direction value at all. I can wiggle it all I like and the sprite doesn't budge an inch. Fantastic for ensuring our hitbox works glitch-free. Right then, so we know what rotation style we are going to use for collisions. So let's try to put this together in the game. We'll begin by finding the When I Receive game loop. Introduce a broadcast before all the others with a new message of tick first. This will be the first thing to run before the other platforming scripts, so it is a good place to switch to the hitbox costume. So add a When I Receive tick first tap block and switch the costume to Big Hitbox. Then, from the motion category, scroll down and find the elusive Set Rotation Style block. Not a commonly used block, but it allows us to switch rotation style to Don't Rotate right here in our code. Very useful. Next, we want to ensure we switch back to the real cat costume after the player has finished moving this game tick. The best place for that will be at the end of the When I Receive tick player script. However, it will serve us well to make a new custom block to accomplish this. Name it Set Costume, and run without screen refresh. Do pop the set costumes block at the bottom of the tick player script, ready to run after all the movement and collisions are done. So, back in the set costume script. For now, we'll keep this simple. We use the set rotation style block again, returning us to the left-right style. Then switch costume to stand. Cool. Later on, we'll come back and add support for player animations, but for now, run the project. Brilliant. Do you notice the difference? Yep, the hitbox has gone. We're only seeing the cat now. Yay! We can move around, and if I rotate my cat, we see the left-right style is working. But importantly, I am not getting stuck when turning against the wall. If I was, then the backdrop would still flash red. Excellent. The other important thing to note is that my cat is still obeying the hitbox rules. I can jump up, but there's no way I can get stuck on his whiskers anymore. But hold on a moment, do you see what I see? Boy, do we have a problem here. Our player can now apparently walk in mid-air. This looks really bad news, and it's obvious enough why it's happening. Let's temporarily remove the last switch costume. Yeah, look, we aren't standing in mid-air at all. No, the corner of our previously invisible hitbox is resting on the edge of the platform. Pop the switch costume back. Well, we know why it's happening, but what can we do about it? Click back into the Player's Costume tab. To ensure our player cannot stand on things to the side of their feet, we need to shrink the hitbox width to be no wider than our player's feet. Also, while we're at it, we can bring the bottom of the hitbox up a little to help prevent our player's feet hovering above the ground, and lastly, bring down the top edge, say to just above his eyes. This allows us to fit through slightly smaller gaps. Great. Select the cat, we grouped it earlier, making this task easier, and delete it. Sorry, Scratch Cat. This leaves us with a smaller and simpler hitbox. I'm excited to give this a test. Click the green flag. Okay, yes, notice right off that our player's feet are well embedded in the floor. You may like this look, or you may want to make some adjustments. Let's see if I can still walk in the air. Oh yeah, super, this problem is gone, and I fall right down as I might expect. And I can collide my head with the platform from underneath. Last check, walk over to the left, and you can see that my head can overlap the walls quite a bit now. This is just how things are going to work for the time being, and you may actually quite like how it looks. In a later episode, we will see some advanced hitbox tricks that will improve things further, and I'm dead excited to get onto that, so let's press on. Coming back to our player's feet then, we can now tweak the bottom of the hitbox to change how far from or into the ground our player's costume appears. Check that out. Yeah, cool. Our feet are nicely placed on the ground. But jump up here. This is why we needed to check. Up here, we seem to be hovering slightly above the ground still. So just in case you had any trouble drawing a good hitbox, you'll find I made one for you. It's at costume 20 and is named Hitbox. You'll also notice that there are a number of other interesting hitboxes in here, but you'll have to just hold yourselves in anticipation because they are not for this episode. We can switch to using this preset hitbox. So I'll delete my big hitbox costume, and then in the code, find the when I receive tick first script, switching to the costume hitbox. Excellent. Well, all this talk of direction and rotation, and yet our platformer has neither. Yet it's so easy. Well, I just wanted to put it off until we had the rotation styles fixed in place. So find the define controls left and right, and when the left arrow is pressed, drop in a point in direction -90. And of course, for the if right arrow pressed, we point in direction 90. Click the green flag. Woohoo! We are on to a winner. This is really looking smart. Being able to change direction at last, we can run and jump all over the place with confidence that our hitbox is in place. And so, finally, we are in a good place to begin animating our player 2. We'll begin with Scratch Cat's run cycle. Here they are in the costume editor. To keep track of the animation, I like to make a new variable named frame for this sprite only. This will hold the animation frame number. We want to animate only while actively walking, so I'll drop a change frame by 1 into both the if key left pressed and right press scripts, like so. Both of them want to add 1 this time. A negative number would actually play the animation backwards. Now come back to the define set costume script. Remember I said we'd use this for the animations? Well, now is the time. We want to switch the costume to the correct ones for our run cycle. Let's take a look again at which ones they are. The run cycle begins at costume 1, then in order goes through 2, 3, 4, and ends all the way down at costume 16. Yep, costume 17 is a jump costume. So that's 16 costumes, beginning at costume 1. We'll need those numbers. Back to the code. We begin by switching costume to the first costume in the run cycle, costume 1, and we'll be adding to this to create the animation. So for now, put in the variable frame. Running the project reveals the beginning of the animation. This is promising, but as expected, our frame variable just keeps going up, and after costume 16, it starts showing costumes that we do not want to show. Luckily, there is a simple Scratch maths operator block to fix the problem, and it's called mod. This is one of my all-time favourite blocks. On the right, we put the number 16. That's the number of costumes in our animation. And on the left, the frame variable. What this does is prevent the value ever reaching the number 16, instead looping back down to 0 again, and again in a cycle, perfect for creating a looping animation. And test again. And this is much improved. Are you getting that happy vibe? I certainly am. The frame variable is increasing all the time as I move, but the animation is kept cycling around, playing like a dream. So now might be a good time to consider animation speeds. Depending on the number of costumes in your animation and the size of the sprite and the speed they are travelling at, you may want to decrease the speed at which the animation is playing back. Let me show you first how not to do this. If the animation was being handled in its own forever loop, we might simply add a wait for say 0.1 seconds after the switching costumes. You'll have seen this sort of thing before. Well, you might think that this would work here, but whoa, this is so broken. That simple little wait has trashed our game. Take it out. Oh, and we are back. So why can't we add a wait here? Okay, let me show you where a wait does work. We need a separate forever loop that updates the frame variable, and then we could update the costume and wait. And if we run just that, you can see this produces the slowdown animation we were after. But in our platformer, the frame is being updated in a main game loop within a tick broadcast. And a tick broadcast, like the tick of a clock, must run very quickly. Any waiting in here is therefore not allowed. So we must find another way to slow down our players' animations. Okay, no problem. We could instead slow it down by changing the frame by a smaller increment. Let's try 0.25 for quarter speed. Oh gosh, there's a problem at every turn. This does slow the animation down without the need for a wait, but has revealed a small glitch in the run cycle. I'm glad we saw this now though, so we can fix it quickly. When we switch a costume to, say, number 16, it's obvious that we get costume 16 on the stage. But what if we set it to costume 16.5? Scratch, in its wisdom, rounds the number to the nearest whole number. And that would round it up to 17. Ah ha ha! So that's where the glitch costume comes from. To fix it, we just need to always round the number down instead. So we do this with a floor operator, wrapping around the frame or the mod like so. And yeah, we now have a stable, slow animation. We can adjust its speed by setting the size of the increments in the change frame block. Excellent. Okay, enough of that. Throw away that forever loop. What I want to do next is bring back the player's idle pose so that we can stand still once the left and right keys are released. We could possibly look at speed X and switch to standing when it's close to 0, but this would also introduce glitches as we change direction. Instead, we will make a change such that frame is set to 0 when we've finished moving. In that case, let's use an if-else, checking that frame is greater than 0. If so, then we use the run animation, but otherwise simply switch costume to stand. Next, find the define controls left-right script. There's a few ways we could get frame to 0 when all the keys are released, but to avoid repetition of code, I'd like us to make a new variable, key x, for all sprites. Sometimes I call this joystick x. Then at the top of the script, we set key x to key right arrow pressed, subtract key left arrow pressed, key right arrow pressed, subtract key left arrow pressed. If I run the project, you can see that when I press the right arrow key, the variable key x becomes 1. When the left key is pressed, it becomes -1. And when no key is pressed, it remains at 0. This is a crazy useful way of storing the key presses because now we can code like this. Add an if-else. And when key x is equal to 0, this means neither the left or right key is pressed. So we can set frame to 0. Yay! That was our goal, to set frame to 0 when no key was pressed. Excellent. Next, in the else, either the left or right key has been pressed, so we can borrow one of the existing key press scripts from before. All we need to do is flip the direction of travel based on key x. Since key x is 1 for right and -1 for left, we just multiply acceleration by key x and do the same for direction. Please don't forget though to restore the set speed x here back to the bottom of the new script before we finally delete this old script. And now let's give that a test. Okay, what do we see? Scratchcat is once more standing upright. That's great news. And his running animation nicely starts up as we run around. What I don't particularly like is that when I release a key, the player stops animating, but continues to slide across the floor. This makes things look uber slippery, an effect that may suit some games, but I'd prefer to make this better. We'll start by taking a cue from the real-world physics, stopping the player dead when they slow down enough. When no key is pressed, add in a new if-else block. Check that the absolute abs value of speed x is less than 1. This means that speed x is between -1 and 1. That's really quite slow at this point. And since no key is pressed, we are going to bring the player to a sharp stop by setting the speed x to 0. Let's see if that worked. Oh, what? Oh gosh, something is so wrong. I cannot move at all. Well, bother. I'm sure the scripts were right. Oh yes, I know. Just click the green flag again. There's nothing wrong here. It's just that editing the scripts with my project still running caused speedx to get set to an invalid value. Restarting things set it back to 0, and from then on it was fixed. Phew, what a relief. So, looking at Scratchy's motion, things are improving. The sliding is a little less severe, but only just. The pose while we slide is also no longer the idle one, but we're not quite finished with that yet. How about we give them a slight walk animation while they slow down? In the empty else, change frame by 0.5. That will give them a half walk speed while they are sliding to a stop. And let's see. Oh yes, look at that. It's beautiful. Isn't it crazy that even though the movement is just the same as before, a little bit of animation has transformed it from looking slippery to being quite natural. Amazing. I love it. Things are coming along great. The final touch is to address our player's jumping and falling actions. At present, you can see the player continues to play his run cycle while in the air. This is not hugely realistic, and we can do better. Scroll up to the Define Set Costume script once more. Now, while jumping, the jumping costumes should overrule all the other animation effects. So, make a space for the new scripts right after the set rotation style. Detect a jumping using if falling is greater than 1, and then simply switch the costume to, let's see, jump 01. We attach the other scripts below. Lastly, put in a stop this script after setting the jump costume. This prevents the other scripts running while we are jumping. Can we test this? Sure we can. Well, that was easy. Boing, boing. Notice that not only does the jump costume show when we jump, but also when we walk off a platform. If we look in the costume editor, we actually have a second costume that may be better suited for the downward phase of a jump. Its name is run_J2. Catchy name. Using another if-else. We'll check for speed y being greater than 0. That means we are travelling upwards. The stop script can move to under this if-else. And while moving up, we can now switch the costume to jump. The whole script can be returned in here. And then lastly, set the costume to that run J2 in the else for when we are falling down. Great, I am feeling really good about this. Run the project. Jumping has never looked so good. We often spend a lot of time in the air in a platformer, so the extra falling costume helps to make things look more dynamic. Well, we are almost done for this episode, but there's one crucial bug that we still need to fix that you've yet to see. Before I can show it to you though, we need to rebalance our game by shrinking down the Scratch Cat to a reasonable size. You can choose to make him any size you like, but in my game he was supposed to be a lot smaller, so click into the size input box and enter a size of 40. Great, wow, so much smaller, but that's okay, I like it. I just need to tweak a few of the variable values under the green flag. Setting jump force back to 12 and acceleration to 1.5. This setup will allow for much more interesting level designs as it gives us more space to run and jump around in. I'm glad to say that we can now also get back onto scene 2 without getting stuck. But not everything is rosy. Let's see if I can show you the problem. I just need to run back and forth here. Okay, obviously more than I thought. Hold on, it's going to happen. There, finally it did, and we got stuck. How is this possible? And why does it only happen now and then? These are very good questions, since we were so careful in the last episode to fix this very problem. All that we changed are sprite costumes. That means this must be costume related. Let's see. Things begin in the when I receive game loop. Our player's costume is set to the hitbox within the tick first broadcast. Next, in the tick player broadcast, the player is moved and the costume gets returned to the cat costume. But then lastly, the tick last is broadcast. Right, the tick last is responsible for detecting the player moving off the screen, and it uses the begin scene script. And here it is. This is where we are having the problem. We are using the fixed collision in direction to get us out of any collisions after switching scenes, which used to work fine. But back then we were using a square costume. Now we would hope to be using the hitbox, but no, we just mentioned that by this point we have been returned to the cat costume. As such, depending on which animation frame we are on, the fixed collision script may not push us far enough out of the ground as it needs to. As such, when we appear on the new scene, we are still stuck in the ground. Luckily, that means it's a quick fix. Switch back to the hitbox costume, and ensure to set rotation style to don't rotate. Move both of these in just before the fixed collision in direction block. Afterwards, we can use the set costume block to return the costume back to the correct costume once more. So, if all goes to plan, that should have fixed our little problem. We can test it by trying our best to cause the issue to happen again, running back and forward like a crazy cat between scenes. Yep, I think we're good. Phew-wee, that is a relief. And on that bombshell, I am going to leave you. But I'm so stoked for the next video because it surely will contain some amazing new content. But what will it be? So many possibilities. Well, you've all seen what we have in store. I do hope you've enjoyed this episode. Please smash the like button and don't forget to subscribe to my channel to catch the latest videos. We also have a channel membership for those most loyal fans to enjoy. Thank you, members. I've seen quite a number of those cool yellow badges appearing in the comments showing you've been with me for over 2 months. Wow, how exciting. So thank you for watching. Have a great week ahead and scratch on, guys.